Everybody. In this video, we're going to be talking about equivalent expressions and specifically how you can design activities to help your students generate equivalent expressions. So remember, the basic structure of a math sentence is that you have two expressions with a relationship between them. And the relationship can be less than, greater than, or equal to, but equal to is definitely the most common relationship that we have. So, pretty much any math sentence will always have this structure, and some of them are really simple, like 2 plus 5 equals 7. So, this is the expression, this is the other expression, and these two expressions are equal to each other. So, we connect them with an equal sign. But you don't want to only do math sentences like this because it can often lead to the misconception that you just put the answer after the equal sign, which is not a idea you want your students to start to develop because ultimately the equal sign is describing a relationship between the two expressions. It's not just a symbol that says calculate this stuff on the left and then put the answer on the right. Even though that does happen sometimes when they're doing their worksheets, that's not the true meaning of the equal sign. So, one thing you can do to help students develop an accurate understanding of the equal sign is you can have them come up with equivalent expressions. So, you can say, I want you guys to fill in the other side of this equation, but you can't use the number 7. And they might be like, well, how can you do that? Because 2 plus 5 equals 7. And you're like, well, here's one example of how you could do it. You could say that it's equal to 1 plus 6. And then you can let the students kind of get creative of, well, how many different ways could we write an expression that's equal to 2 plus 5? And that will, first of all, like build their curiosity around math because it's kind of an interesting question because there's lots of ways you could do this. You could also say something like 2 plus 5 equals 1 plus 1 plus 1. Whoops, I missed some of my ones. Plus 1 plus 1. That would be one way you could do it. You could also write it as, 15 minus, goodness, 8, I think. Hopefully, I did my subtraction right. But that will really help the students start to understand the idea of an equal sign as a relationship. And you can also help them generate equivalent expressions that communicate important mathematical concepts. Like, for example, that 2 plus 5 is equal to 5 plus 2. That's a very critical mathematical concept to understand. And you can have conversations as a class about why that's true. And if it's always true for any number, like if you do A plus B, is that always equal to B plus A and why? You can do something similar for multiplication. Or you can also illustrate other important mathematical concepts like that 3 times 7 equals 7 plus 7 plus 7. That's an important understanding to have. Or possibly that 2 times 18 is equivalent to 2 times 10 plus 2 times 8, because that concept is going to be very helpful for multi-digit multiplication. Um, and so there's lots of different ways that you can introduce this idea of equivalent expressions. And when you want to introduce a equivalent expression that communicates a fundamental concept of mathematics, like for example, this one, that multiplication is the same thing as repeated addition, or perhaps that the order doesn't matter when you add numbers together, you can design activities that will help the students realize this for themselves. And the way that this typically goes is you design a word problem that you can imagine the students solving in multiple different ways. So, for example, if you had the problem where 5 children each have one Snickers bar, one Kit Kat bar, one Reese's peanut butter cup, and one Butterfinger bar, and you ask the students to figure out how much candy they have all together, it's likely that the students may have different strategies for doing this if you let them work independently or in groups. Because some students might think about this as 4 plus 4 plus 4 plus 4 plus 4, because each of the children have four candies. And so you just add four together 5 times, and that tells you that you have 20 candies. But other students might think about it differently, and they might think of it as, well, I have 5 Snickers bars and 5 Kit Kat bars and 5 Reese's and 5 Butterfingers. And so that's why it equals 20. And when you come back for a whole group discussion and you talk about the different strategies that the students use to solve this problem, you can have a conversation about, why is it that this is equal to this? Like, why did those two things give us the same answer? And if you ask the students to explain why they're equal, and you let them use pictures or blocks or various methods, they can actually come up with some pretty advanced ways of thinking about it. And ultimately, giving them the time to think through that is going to give them a much deeper understanding of the mathematical concepts. And ultimately, what is underlying this conversation is the idea that 4 times 5 is equal to 5 times 4, or in other words, the commutative property of multiplication. And especially if they're just starting to learn multiplication, you might have to have a conversation about why this is equal to this and why this is equal to this. Um, so that would kind of add another dimension to the conversation. But ultimately, that would be the relationship you'd be trying to help them discover. And any type of mathematical relationship that you want them to discover can be encouraged or facilitated by creating a word problem that can be solved in multiple different ways. So, I hope that this video was helpful, and I hope that as you're teaching your math lessons in your classes, that you start to think about, how can I encourage my students to recognize these mathematical properties and really understand the meaning behind them, rather than just telling them that this is a fact. Because you could just tell them the order doesn't matter when you multiply and then move on. But if you let them realize why the order doesn't matter, it will help build their conceptual understanding of multiplication, and it will make that property much more meaningful for them because they'll have discovered it themselves. So, I hope this video is helpful. If you have any questions, let me know.